I'm Philip Connery.
Nice to meet you, Philip. Jake Hoover. This is Randy. Hi.
Randy, nice to meet you.
You too.
I'm Michael Brummer.
Michael, nice to meet you. Is everybody going to come up? Hi, Randy.
Well, we'll introduce ourselves too, but you want us to come up? That'll work.
Oh, yeah, sure. Okay, Randy,
Go.
David, Jake, nice to meet you.
Randy.
Jeremy. Jeremy.
Sam Drew.
Jeremy, Randy. Sam Paul.
Sam.
I'm Hannah.
John Paul.
John Paul, good to meet you.
Hannah. Nice to meet you.
This is Team 9886 MASH. We are actually a homeschool team, so everyone here is homeschooled. And we, at the beginning of our season, we made a couple goals, and I'll show you. These are mostly robot goals on this. Here you go, look at this. So I intended for our scoring to be, we were going to do everything for autonomous, and then we were going to get 6 stream minerals in the cargo hold, which is in the lander, and then 40 minerals in the depot. That was our low score, is what I was planning. So here's where we've achieved so far. So we do autonomous pretty well, and then we've got the robot latch to the end, that's 50 points. But right now we're stuck at about 6 minerals in cargo hold, which is kind of interesting for what I thought we could do on it. And we hope to get better than that. So it gets us around 160 to 130 points. But those are the goals, and that's kind of how we turned out. I set up these goals right at the beginning of the season, and you'll see them in the notebook. And then I went back over it just recently and realized, oh, we're not that close yet. But for outreach, what we do is I've kind of divided our outreach into 3 sections. We have community and business outreach, and then we have team-to-team outreach, and then we've got more personal outreach. The community and business outreach is kind of interesting. We have sponsors like a lot of the other teams, and you guys will see it. This is your first round, so coming up, a lot of the other teams have lots of sponsors, even more than we have. But what's really interesting about our community and business outreach is that we have a connection with our city where we meet. It's called Hudson Oaks. You guys know where that is, maybe. And well, it's out by Weatherford.
Oh.
And we actually got to present our robot before the mayor and the city council. And the mayor issued what's called a proclamation. I had no idea that could be issued or anything. But it's basically, he said, March 22nd is to be remembered as Mesh Day. It's kind of fun.
Really? All right.
It's a nice thing. And then we have the team-to-team outreach, and that's mostly visible during our competitions. We'll go, like JP helps out a lot with software. He's real good at that. So he'll go to different teams and help out with software. Then we've loaned parts, and actually this competition we have some of our game elements are being used for the competition. And then team to personal outreach, we went to the Ronald McDonald House. Have you heard of that? Yeah. Yeah, so we went there and did an entertainment type of deal there. That was actually pretty fun. Pretty interesting too. They really decorate for Christmas over there.
And at that, we had kids driving the robot, seeing what it's like.
Cool.
So, I'm Michael Brummer. This is my first year. I'm David Brummer. This is my first year.
I'm Jeremy Burgess. This is my first year. I'm Samuel. This is my 3rd year.
I'm John Paul, and this is my 5th year.
I'm Hannah Burgess, and this is my first year.
So John Paul, what brought you back to do it again?
Well, fell in love with it my first year. Moved this last year, and ended up finding this team, and I like them, so I wanted to spend my 5th year working with them.
And you would be you've been here the longest of all of them. And you said how many years?
I've done about 3 years.
3 years? Okay.
He's new to the team.
I'm new to the team.
Oh,
But it's his fifth
Yeah,
year.
this is my
Okay.
5th year doing FTC, but it's my first year with this team. I've really been enjoying working on it.
So we transported the brains from somewhere else and put them in.
You recruited him, right?
Okay, so what I'll be talking to you gentlemen about is the actual function of the robot. A lot of times I think teams come in here and kind of explain all the different technical parts, but you don't really see what it does first. So first I'm going to explain to you the drivetrain. These are the Mecanum wheels that we've chosen. So not only can we go forward and backwards, but we can also translate left and right without rotating the body of the robot. And that makes it very efficient at going around the crater without turning and making rough turns, and makes everything smooth over and a lot faster. This right here is our arm. We have these Andy Mark extrusions here for the arm, and it extends out probably to about here. With this, it's a collector box is what we call it, and this is what we use to collect the minerals and the game elements to score them, and we'll collect them here, and the arm will rotate up and dump them into the lander. Next we have our lift system. So this right here will extend out. This uses a worm setup.
Lead screw.
Lead screw, yes. And so this will lift up and hook onto the side of the lander and lift it up, and that's capable of like 45 pounds or so of weight. And the last main portion of our robot, the main function is this right here. This is our team marker, and this sits here, and this servo will just release it in the autonomous period and drop it in our team's depot. And so that is our basic function of the robot. So now you can kind of understand what they're talking about when they explain everything else to you.
So I'm going to explain our design process. So first we had to read the rules and to know what we were doing. Then we had to brainstorm ideas. And once we brainstormed the ideas, we picked the best ideas. And you take that idea, you make a prototype. And then you test the prototype. If the prototype doesn't work, you go back to the brainstorm phase. And you redo that till you get the best idea. And once you get the best idea, you design it in CAD. See, we've done this part multiple times in CAD. Then you build it from CAD. Once you build it, you test it. And if it doesn't work, then you have to rebuild it or go back all the way back to the brainstorm phase. Thank you.
How many different iterations did you guys have to come to for this design?
The chassis, one, this is the second one.
Two iterations.
2 iterations. This, we've come up with a couple ideas. We've tested them a little bit, so probably about 4. And this, 2 or 3.
So that was by far the hardest if you did it 4 times? I imagine.
Yes.
Because we started with we really focused on the arm before we focused on the collector, so we had to figure out something that would fit in the space while also still being able to allow us to score properly.
So I'm going to be talking about the design iteration for the arm. So our first design idea was to just have the basic arm on a pivot with a claw that goes down, picks up the mineral, and then we go to the crater and drops it off at the lander. But the problem with that was that it wouldn't be very efficient due to time. So being able to only pick up one mineral at a time as the maximum wouldn't be very good for our team given the time period. So our next idea that we had was a conveyor belt idea, which was to have a collapsible conveyor belt that would fold out of the robot, and then we'd have a little kind of like a scoop that would pick up the mineral and put it on the conveyor belt, which would take it all the way to the lander. But the problem with that was it wouldn't be very practical with only 2 minerals at a time on the robot. So it would go pretty slowly, and besides it might get in the way of other robots trying to get around the field. And so another idea that we had for the collection was to have basically a hollow cylinder with duct tape wrapped around the mouth. And then a hole would be in the middle of the duct tape that would be about the size of a block. So we would jam the cylinder onto a mineral, and it would collect the mineral, and then we'd dump it into the lander. But the reason why we didn't use that was because we weren't sure exactly how much force would be required to jam it onto the mineral and pick it up. But we knew that with the arm fully extended, we probably would not be able to get that much force to pick up a mineral. So now what we have is we have this slide that extends out, and when we get to a mineral, then this little sprocket over here rotates, and then the brush rotates and picks up the minerals. So this part that I'm holding is a part that 2 of our team members designed on CAD, which would be to have an Robotics or an X-rail in this hole with T-nuts on the side, so we could have it in there with screws. And then this would be like the pivot where it would rotate on the axle with bearings inside of those holes. And then we'd have a little counterweight over here. But we didn't use this mainly because it wouldn't be strong enough to hold up the entire arm and the counterweight for the arm. So now what we have is a sprocket over here on the motor that rotates, and then it turns this gear over here, and it turns this the axle, right? Yeah. That you have, well, there's an axle going through that C channel, and it rotates that. So, pretty much it for me.
Over the previous years, we've tended to build a robot and oh no, it doesn't work. And we tear it apart. We do that like 3 times. So and that usually takes a lot of time and you never really get to really what we want. This year, we really focused on CAD. Everything below this point here was entirely built on a computer before we built it up to what it is today. All these orange and white parts were either 3D printed or cut out with a CNC machine. This part right here was built with a CNC router, and this aluminum part right here also was. But all the orange parts are 3D printed. We have 36 3D printed parts on our robot.
So our software is split into 3 main groups. They build up in order from top to bottom. The top group is the op modes. That is your teleop and autonomous programs. We have 2 autonomous programs, one that works from the aiming position nearest to the crater, and the other one nearest to the depot. The next group are our extensions. These are Java classes that feed into each other and into the op modes. This includes a autonomous driver, which allows us to navigate the field using a gyro sensor, which makes us a lot more precise in our movements, and our hardware configuration, which combines our next group, which are called subsystems, into one file, which we can then call in our op modes to make the code a lot cleaner. The last section, as I mentioned before, is called the subsystems. The subsystem is each individual major part of the robot that has to operate independent of other parts. Each subsystem has its own class, which explains the functions that that subsystem can do, defines the motors, servos, or exclusive use sensors, and gives them functions and telemetry.
I'm going to be talking about the controls, but first we have the mecanum wheels. We have them turned sideways so that the collector device will be in the front, so the robot drives this way with the collector in the front. So we have our 2 controls. One operates the drive, and the other is the arm and the collector.
There you go. You guys can have it.
No way. Fall off and break, and then you guys have a bad day.
Well, we'll leave it off.
So for the drive, the thumbsticks, they operate the drive train, and then the D-pad operates it slowly, so it's left, right, front, and back. The Y button, these 2 operate this lift, so this raises it up and then brings it down. And then these, the triggers, are translate, so translate left and right. Yes.
These are translate.
Yeah.
Very
One
rather
interesting
hard.
thing about the way that we drive is our robot considers this the front of the robot during teleop, which is a bit different than normal. Most teams, the side that the wheels are pointing towards is the front, but
most mind-boggling thing about driving the robot?
We did it because we thought we'll have an advantage, because the motion front and back is actually rather less than side to side, especially if you're going to get the gold into the lander. So you have to go forward, back, and then you got to swing around the corner of the lander. And we thought we could do that a lot faster doing with these wheels like this.
What are the wheels called again?
Mechanism wheels.
Mechana.
Who's driving it today?
There are a number of drivers. I'm a driver, Sam's a driver.
I'm a driver, and she's a driver.
Yes. Jeremy is as well. Right?
Yes. Or a
So,
coach.
and then this one operates the arm and the collector device. So this thumbstick raises the arm up and brings it down. The Y button,
We at a time?
You're on time.
Okay,
alright,
you got,
I gotta get a picture.
okay.
well, thank you guys so much for presenting your robot. That's, yeah,
No,
great.
you guys move back with the robot.
We want our controls back.